currently in the United States for a typical robot deployment, the timeline from decide to do a robot deployment to actually see the system installed is typically on the order of magnitude of 4 to 6 months, given all of the steps involved related to that kind of site preparation, system installation, procuring all the parts and components, programming, things like that. So we are typically doing that in about 2 weeks. So that's kind of a massive savings on kind of deployment speed. In terms of costs, it's there's a lot more kind of fluctuation depending on the type of system. So the benchmark that we use is similar systems, and we're able to as you're I'm sure familiar, for typical robot deployment in the U.S., 60 to 70% of the cost involved is in custom engineering services. That custom engineering can be anything, right? It can be figuring out what the thickness of the concrete is that needs to go, beneath the system. It could be configuring end-of-arm tooling. It could be designing all the safety configurations and interlocks and safety fencing and where the safety scanners need to be. And all of them are site specific. So these are not things that you could say, oh, I have an AI powered robot that's much smarter, so I don't need that anymore. Right? Like all of those things, regardless, need to happen. And so, we are able to reduce that portion of the deployment to near zero because we've automated most of it, not by kind of making the robot more intelligent, but by kind of focusing on those specific processes where there's a lot of time and energy that needs to go into robot deployment. So those are the kind of the two axes that we think about. The third one is kind of total cost of ownership of a robot. So the kind of initial upfront deployment cost of a robot is typically, only one portion of if you're a factory and you want to deploy robots, the upfront cost is one portion. The really big cost is actually the ongoing service and support, right? Your needs change, your programming needs to change, your configuration, hardware configuration needs to change, your safety configuration needs to change, and then robots wear and tear is kind of natural, right? And as all those things start to happen, there's a huge cost that's typically incurred on the order of magnitude of 10 to 15% of the cost of the system per year to keep that system up and running in a kind of performative state. And that's one of the areas where all the software and tooling and kind of operational excellence that we've built drives that down significantly as well.
That's really cool. How do you expect, so when you were saying like safety related things might change, what does that mean? Like, why would safety things change during the course of operating? Is it just like new standards? They're doing new processes, or why are some of these things changing? I suppose.
Yeah. So like, I'll give you a very simple example, right? If you are just picking up boxes, if you're picking up a 10-pound box over and over and over again, there's a certain kind of safety regime associated with that. If you're picking up a 40-pound box or a 60-pound box or an 80-pound box, just that, even if it's the exact same operation and the exact same movement, the safety constraints associated with that suddenly change a lot, right? Because if that box drops when, let's say, the kind of compressed air stops coming to that system, the system loses vacuum, and that box drops, the damage that's caused by a 40-pound box or 10-pound box are very different. So that's that's a very trivial and small example, but the production needs in a manufacturing facility are not static, right? There's always things that come up, and as those configurations need to develop, you need to readjust, you need to recalculate all of your safe distance calculations. You need to figure out what happens if somebody enters the cell prematurely. Does the robot go into emergency stop, or does it slow down? How does it slow down? What are the things that it's interlocked to? What are the safety scanners that you need to have in order to support that? Like, there's all these things that need to be addressed, and the maximum speed that robot can operate will be different. Like if you're let's just say you're stacking that box into a pallet configuration, the maximum height that you're able to reach will have to change. So there's all these things that are just fundamental physics related things that you have to address. And I think that there's a lot of optimism around kind of AI powered smart robots that will solve all of that for you. Unfortunately, that's not really the case, right? I think the AI on the robot will make it easier and easier and easier to program the robot to do that task. But at the end of the day, there's still all of these other considerations that go beyond, can I make robot move from A to B, there's all these other considerations that need to be taken into account. And what we've found is that there's not a lot of emphasis being placed on those things right now.